Solving ISS 2021 paper 2 question number 48. Let x and y be two independent random variables with uniform zero theta. We are testing h naught theta equal to 1 against h1 theta equal to 2. The probability of type 1 error and power of the test for critical reason x upon y greater than 0.65 are respectively. Okay, so we need to find the type 1 error and power of the test. So type 1 error is alpha and power of the test is 1 minus beta. So type 1 error is probability that x belongs to rejection region under h naught. So the rejection region is given to be y excluded by 0 greater than 0.65 under theta naught means under h naught. Under h naught theta equal to 1 means theta equal to 1, and similarly the power of the test will be probability that x belongs to omega. Omega means the critical region under h1 means probability that x upon y greater than 0.65 under h1 means theta equal to 2. Okay, so to find this probability we need to find the distribution of x upon y. So it is given that x and y are independent uniformly distributed with the parameter 0, theta. So since they are independent, so their joint density will be the multiplication of the marginal densities. Okay, so we can write the joint density like this. Okay, 1 by theta into 1 by theta is equal to 1 by theta square, and the limits of x and y will be this. Now since we need to find the probability of x upon y greater than 0.65, so we need to find the distribution of x y upon y. So we can do it by using the Jacobian method. So we can let's assume z is equal to x upon y and v is equal to y. Okay, so we can find the joint density of u and v, and then we can find the marginal density of u, and then we can find the required probabilities, which are these two. So to apply the Jacobian methods, assume this, and now find the x will be u into v because y is v here. So write u and v in terms of x and y here. Okay, and find the Jacobian. Okay, so differentiate x and y with respect to u and u. So here will be v and 0, and similarly again differentiate x and y with respect to v and v. So if you differentiate respect to v, there will be 0, and if you differentiate respect to v, there will be 1, and find the determinant, so it will be v. Now so there joint density of u comma v will be marginal densities of x comma y and Jacobian. So Jacobian is v, so write v, and their marginal density of x and y is 1 by theta square. So put here, so we are getting v by theta square as the joint density of u and v, and limits of x and y are like this. Okay, so just put x and y values in terms of u and v here. So x value is uv and y value is v. So put uv here and y is equal to v here. So we are getting limit as 0 lies between, so we are getting limit as this, and second is this. Now to find the marginal density of u, you need to draw the graph first. Okay, it is important. So this is u, this is v. So first draw this. Okay, so v is equal to theta is, suppose this is theta here, so this area will be our v is like between 0 to theta, so this area representing this inequality. And similarly uv greater than 0. Okay, uv greater than 0 means both are positive and both are negative, means this area, and we have considered this area, and now we will consider this area, uv less than theta. So this is basically in terms of xy barabar k, which is the rectangular hyperbola formula. Okay, so rectangular hyperbola is like this. Okay, so and uv is less than theta, so thus our required region will be this. Okay, so Now next we need to find the marginal density of u. So for that we need to draw a perpendicular line with to u axis. So draw this. Now here you can see that the curve changes. Here it is v is equal to theta, and here it is uv is equal to theta. So we need to integrate in two different regions. So we need to find this point. So this point will be solution of these three inequality. So uv बराबर theta and put v equal to theta here. U into theta बराबर theta, u is equal to 1. So this point is 1 here. So we need to integrate in first in this area and then in this area. So this is the area. So since limit of u is 0 to 1, 0 to infinity, but we need to integrate in two parts. Okay, so right u lies between 0 to 1, and right u is lying between 1 to infinity, and then draw a perpendicular line. Okay, so its limit will be v is equal to 0 to v is equal to theta, but if you integrate in this region, then limits will be v is equal to 0 to uv. Here find the value of v here. So v will be theta by u. Okay, so limit of v will be v is equal to 0 to v is equal to theta by u. Okay, so fu will be the joint density of uv and integrate with respect to v, and limits of v are like this. Okay, so if you solve this, then you will be getting this. Okay, but here you can see that there is no theta here. Okay, so it is independent of theta, means if I will put theta equal to 1 or theta equal to 2 here, our density will remain the same. Okay, so the type 1 error is this. Okay, so we have assumed this earlier u. Okay, so this will be plotted as u greater than 0.65, but the distribution u is independent of theta, so we don't have to worry about this. So now you can see that 0.65 is lies between 0 to 1. Okay, so we can simplify it by using this. Okay, because the sum of the if we integrate the density function with respect to whole limit, then it will be 1. Okay, so this probability can be written like this. So now this probability can easily be calculated, okay, by using this. So apply this. So we are having the lower limit is 0 here. Okay, now if you solve this, then you will be getting 0.675. and similarly for the power of the test, so probability that x belongs to omega under h1 is true. So this means probability that u is greater than 0.65 under theta equal to 2, but the distribution u is independent of theta, so we don't have to worry about this. So probability that u greater than 0.65 will be same as this, okay, which is 0.675. so we are getting both as 0.675 for so option A is correct.